So we are going to look at, we are going to look at calculations of genetic frequency. Calculations of genetic frequency. The first example here says, consider that we had a partial trait of capital BB and small bb. What percentage of this express the percentage of BB and BB out of 497? Out of 497, BB is 452. BB is 3, while this is 2. Now we are asked to write the percentage of each of these. That's what this question means. So the first thing, the very first thing and the most important step here, whether you know what to do or you don't know what to do, is to write solution. And put 2 lines under. Now, after the solution, first we are given BB as what? Sorry, the total population is what? 497, right? We are given BB is what? 452, right? This is what? 43, and this is what? Now, if you check very well, this capital B, we call it homozygous what? Dominant, right? Remember, dominant, we write capital letter dominant. If it is small letter, recessive, right? Homozygous if they are both capital or both small. So this is homozygous dominant, right? And this is what? Heterozygous, right? Dominant. And this is what? Homozygous recessive. Now we are asked to find the percentage of this, the frequency of this. The total population out of this 497, 452 persons were homozygously dominant. 43 persons were heterozygously dominant, and 2 persons were homozygous what? Recessive. Now, the frequency of capital B is equal to 452 out of how many? So we have 452 all over what? 497, which will give us what? Bring out your calculator, everybody. Place it on your seat. If you are not with calculator, stand up. Alright, so 452 divided by this will give us what? 0.909. You can convert this to percentage by multiplying by 100, right? Good. Frequency of the heterozygous here is equal to, how many did you have before? 43, right? 43 all over what? 497 will give me what? 0.087. Now the frequency of small b will give me what? 2 over what? 497, which is what? 0.004. Now, if I'm converting this to percentage, I'll just multiply by 100, right? So this will be how many percent? 90.9%. This will be how many percent? 8.7%. This will be how many percent? 0.4%, right? Now, if you notice, we said frequency is between 0 and 1, just like probability. Between 0 and 1. Probability cannot be less than 0 and cannot be more than 1. Probability cannot be less than 0 and cannot be more than 1. If the probability is 0, it means it will not happen. What is if they say the probability that rain will fall today is 0, it means it is certain that rain will not fall, right? If the probability is 1, certainty 2, it must happen. If they say the probability that rain will fall today is 1, better stay indoor because rain must fall. Do we get? Now, if the probability is half, like if my first child is a May, second May, third May, fourth May, fifth May, not me, Now, what is the probability of my sixth child being a male? Half, right? Half. Still have 0.5. Good. So this now, if you add everything here, it will give you 1. This plus this plus this will give you 1. Suppose. This plus this plus this will give you 100%. Good. So this is what we asked to do. That's all. Alright, let's look up please. Now, this question says, imagine a population of 1,000 diploid individuals. We know what diploid means, right? Diploid. 2, right? The chromosomes are arranged 2, is it not? Diploid individual with 353 AA or dominant, 494 heterozygous. You know, when one is dominant, one is recessive, is heterozygous, right? And 153 homozygous recessive. Good. Find the allele frequency of AA alleles in the population. AA alleles in the population. Now, to find the allele frequency of AA alleles in the population, this is the formula you use. You would use 2 times the capital H here, homozygous dominant. You can write it out in full. I decided to write it short because of my space. So 2 times homozygous dominant plus 1 times heterozygous dominant plus 2 times homozygous recessive. Now, homozygous dominant, is it AA? Is it this one, or this one? So 2 times capital A, this homozygous dominant plus 1 times this heterozygous what? Dominant. Is the heterozygous dominant is what? Is this one, right? Don't give up yet. You understand? I will spell out something that 2 times the homozygous recessive is AA, right? All over the total 2 times the total population, the number of individuals. The total number of individuals we have there is what? 1,000, right? Don't worry, just get it to the end. I'll take it again, and you must understand you don't have a choice. Now, 2 times AA, we're giving AA there as what? 353, right? So 2 times 353 plus, we're giving capital A, small a there as what? You said what? 5494. Don't write yet. I'll give you time to write. Plus 2 times, we're giving AA as what? 153. All over. This is supposed to be 2 times 100, right? Is it not? Good. Sorry. King Matthew. Excuse me, please. Okay. All right. Now, what are we asked to find? The allele frequency of AA alleles, right? Listen up. Stop writing now. I'll give you time to write. We are asked to find the AA alleles. Now, if you look at this, hello. If you look at this, yeah, in AA, this one, how many of these alleles do we have? Just look at this. AA, AA, AA. How many of the capital A alleles do we have here? 2, right? Hello? Please listen up now. We have 2 of these A alleles, right? 2 of it. Yeah, how many of these do we have? 1, right? Yeah, how many of the capital A alleles do we have? The capital A allele, how many do we have here? We don't have anyone, right? And the A question says we should find the allele frequency of the A alleles, right? So this is what we are looking for. Yeah, if you look at this, 2 times homozygous dominance, right? 2 times homozygous dominance. Where is the 2 coming from? The homozygous dominance, we have 2 of the alleles there. Is it not? plus 1 times the homozygous dominant, is it not? Listen, heterozygous dominant, because we have only one of it. Now, this 2 times homozygous recessive here, this formula here is a general formula. But in this case, AA, here, homozygous recessive, there is no A allele here. So in our solution here, this will be excluded because the A allele is not there. See why I was asking you to stop writing? I just wrote it out, so I'll use that to point it out. Do you get what I'm trying to say? Let me take it again. In this question, A says find the allele frequency of AA alleles. To find the allele frequency of AA alleles, this anywhere you see capital A is what you're interested in. Where you don't see capital A, you leave it out. In essence, this is what I'm saying. For the AA alleles, yeah, you know, in the population we have all this, right? AA, 3 of these. But in this, in the homozygous dominant, how many do we have? We have 2 of the alleles there, right? So we said the allele frequency of AA in that population is equal to 2 times AA, right? The population of AA, because we have 2 of it here. Plus, in this one, we have only 1.